Good morning.
In my own little way, I see environmental monitoring as a systematic approach of
Sir, please, we cannot hear you.
of identifying and measuring uh, environmental factors like air, soil, water, biodiversity in a quest to identify individual parameters that will lead us to finding better ways of conserving our environment. Thank you.
Okay.
Hello, sir.
Yes.
Can I
Any
attend?
attempt?
Yes.
Yes, sir.
Yes, sir. Good
Okay.
morning, sir.
Good morning.
Good morning, sir. Yeah, my name is Michael.
Yes. Good morning.
Ibe.
Okay.
Yeah.
Okay.
Okay. Yeah, environmental monitoring is a systematic scientific process that involves the observation, measurement, and evaluation of environmental conditions over time in order to understand environmental quality and also detect changes to support evidence-based and decision-making.
Okay. Very, very sound. I like that.
Okay,
Okay.
good
I
morning,
think these
sir.
two. Hello.
Good morning, sir.
Yes. Yes. Good morning.
My name
You want
is,
to make an attempt?
yes, sir, I want to make an attempt.
Okay.
Environmental monitoring is the regular observation, measurement, and recording of environmental conditions, at least to understand what is happening in the environment and how human activities
I'm
or
listening.
natural processes are affecting the environment. Now, the
Okay.
measurement can be the air quality, water quality, soil quality, biodiversity, and then the weather and climate condition or weather and climate data.
Okay. Okay. That is fine. Let me give you a prelude to this concept of environmental monitoring. You see, man is a prominent player in our environment. Do you agree with that?
Yes, we do, sir.
That
Yes, sir.
man is a
Yes, sir.
prominent player. Our activities alter the balance of nature. Man is constantly in the quest to make the environment better, safer, depending on what he desires at a particular time. And so all our activities of urbanization, industrialization have constituted a menace to the environment. We have distorted the habitat. So many species have been lost. They have migrated to where they feel is safer for them. We have introduced a lot of toxic substances into the environment. And let me also tell you that when you take something, introduce something new into a place, or you take something from where it was and drop it elsewhere, you have tilted the balance in nature. And this is where we found ourselves today. The program you are in currently was designed you to train professionals that will have more understanding of the need for a better and safe environment at hand, and that will inform decision making and project implementation such that we can march towards this environment. Hello.
We can hear you, sir.
That person is shouting in the marketplace. Can you please off your mic?
You can mute everybody now. Mute everybody until the lecturer, please.
Let the lecturer open.
Hello.
Okay, until I'm added as a co-host, just wait. The host will add me as a co-host that we do the needful.
Please, Constrate, can you unmute everybody so that we can wait for the lecturer to complete?
Hello.
Can you hear you, sir?
Okay, Doc. Thank you, Dr. Thomas. You can unmute yourself now.
Fine. Okay. So I was saying that it is important for us to realize that we need to have a conscious effort towards managing our environment to a safe place where we can have a sustainable utilization of our environmental resources. So, in totality, environmental monitoring involves tools, techniques that have been designed to observe the environment. So you can see the critical thing here. The tools and techniques that have been designed to observe the environment, characterize its quality, establish its parameters for the purpose of accurately quantifying the impact and activity have on the environment. What this means is that if you remember, Dr. Fegbu in one of his classes was telling you about the use of GCMS. He said GC, we identify the gaseous pollutants, while the MS we quantify. Do you remember that statement? He said the MS we quantify. And so this is what we do here. We need to monitor our environment from the air, water, soil, our food. These are all been elucidated in the various classes you have had so far. And I believe from your responses, it is part of you already. I believe it is part of you already, and we are actually going in the right direction. Now, if we already understand the concept of environmental monitoring, For example, Dr. Fegbu, in his first case study, now if you look very closely at the Uruku roundabout, the mitigation process is already on. We pass through it, we walk through it, but many of us will not understand it. Let me give you an idea. Do you see that every morning as they are walking, they pour water on that space? Hello, at Uruku roundabout. Do you realize that they always wet it in the morning?
We are all mute, so you can continue, sir. We are hearing
Okay,
you.
fine. That's, but at least you can understand what I'm saying. So you can see that they pour water. Why did they?
Yes, they are pouring water. Unmute yourself, sir.
We can hear you, sir. Yes, they pour water.
Yes.
Yes, I hear you, sir.
They spread water on
the dust particles.
the dust particle. They pour water to prevent the dust particle.
Doc, you can unmute yourself, sir.
They pour water to mitigate impact.
To mitigate the level of the dust accumulated in the Urukun roundabout.
Yes, don't worry now. I'm just shaping your mind towards that discussion.
So, Doc,
So,
now
Yes,
that I have
hazard
responded,
control.
sorry, Doc. Now that I've responded, I'll have to lock off
yes,
again.
don't worry. Lock them down, please.
Sure,
Then
go ahead.
you can now answer. So, Doc, you can now on your mic, sir.
So this is what happens. That mitigation process, now cushioning the effect of what they are doing gradually while the work is ongoing. It is important that in all that we do, we need to realize that we must monitor the environment every inch. In our homes, from the beginning of the day to the end, we litter so much. How do we manage household waste? If we don't do it, for example, your wife is a banker, and maybe you are somebody that travels a lot, and you are not even there to assist. Maybe there is no house help. You know that the sink may remain like that for some homes throughout the day, or maybe the weekend. You know what I'm talking about. And for some that are very smart, they come back, they make sure they clean up before they sleep, whatever. But once the sink is not done, you can imagine what happens in that kitchen. Not to talk about the other things around the house. So if you take from that example, it is very, very important to us. So while it is critical, where mitigation measures are being suggested, that if you check the lectures you have had so far, majority of the approaches to even characterize the pollutants in the environment has to go through a chemical process. So, but environmental sustainability is here to tell us that no matter what we have gone through to establish whether the environment is safe or not safe, we must return the environment to its status quo, whereby we can guarantee the safety of at least everybody. Where we cannot take away completely the damage that has been done or the danger, we reduce it. If we cannot reduce it, we avoid it. If we cannot avoid it, let us do something that can amend the environment in terms of mitigation. And so I like us to look at the probable use of biological agents with a view to allow a natural process to occur in the environment while it is resolving or removing the danger from the environment. And this is what they call the principles of bio remediation. Okay. Now, after a major episode,
Okay,
maybe
so we are not seeing your screen, sir.
No, I'm not sharing the screen yet. Just
Okay.
let's get overview. Yes.
Okay, sir.
I'm not sharing the screen yet.
Okay, sir.
Yes. So when there's a major episode, maybe an inferno, that is an episode of fire with high intensity that destroy almost every life around the space, or maybe oil spill over a prolonged period of time, a volcanic eruption, okay, any natural disaster, or even an accident of any sort that have consumed the environment at a particular space. And you are invited. What do we do to this space? How do we overcome this condition? Maybe it's a land mine. There was a mining activity over some time, and now the environment is devastated. Yes, this is a proven case of habitat destruction. Ordinarily, we're supposed to monitor the environment to sense the danger, but this activity is a colossal one that destroyed the environment immediately. We still need to monitor whether we can rehabilitate this space, whether we can bring life back, whether we can make it look like what it was in the pristine condition, or just to make it functional again. Let me also tell you that the courses, the various course units you are doing, even the topics within one course are interwoven. And so one knowledge will your mind around the things that you have learned so far. So we look forward to concepts like habitat reconstruction. We look forward to concepts like revegetation, afforestation, reforestation, habitat recovery. Let me start with the last one. Habitat recovery is simply to bring back life into a lost habitat or a destroyed environment. And you know, nature in its wisdom provided a feedback mechanism that the environment can overcome its challenges if the stressor elements are not there or are reduced or removed completely. But then there are some ingredients, natural ingredients in the environment, and these are plants, microorganisms, and some what we call keystone species, both plants and animals in the environment. So a synergistic effect of the consortia of all organisms living in an environment can make things work. Some plants depend on others to survive, while what they are surviving on is not important to that plant. They are growing, but then their relevance in the environment is enhanced. Okay, some plants live on top rocks. You have seen mosses growing on concrete walls or on top of large trees. They don't have roots that comes from the soil that you can say that they are taking their nutrient from the soil. Some of them get their nutrient element from the air. Some of the gases that are poisons in the environment are what they feed on, they rely on. Nitrous oxide, for example, enters through the stomata of we call it porifers of sphagnum Okay, there's a type of moss. These are great plants. These patches, okay, you see them on concrete walls and on large trees. So by feeding on these gases, which are pollutants in the environment, they are growing. So it's not everything we see we need to destroy. So for example, at working roundabout now, if the flyover is made and maybe the next 20 to 30 meters, the whole of that busy area, because of vehicular emissions that may be concentrated at that space, will have giant trees that are planted, although not really looking wild, but looking beautiful in a way that some epiphytes can grow on top. They grow there naturally. They will help purify the quality of air from that space. We see them on the road, but we don't know what they are. So, as construction men and women, as engineers, urban planners, town planners, sometimes we see things that others have done we will not understand. It is important that we look inwardly and see how some elements of nature can naturally come in, either as monitoring agents or as also mitigation agents. Now, for you to, having identified the concentration of pollutants in an environment through chemical analysis, you see there are two approaches in mitigation here, in bioremediation, which is a mitigation strategy. It's either you attack that system where you notice it, or you have to extract the forces out of that space and deal with it. What am I saying here? There's what we call the ex situ procedure and then the in situ procedure. In situ, that is dealing with the pollutants on site of pollution, while ex situ is extracting the pollutants off the site and then scientifically designing a method of dealing with them, and then you can then reintroduce that into the environment. Okay, so I'm giving you this idea so that when you do the assignment, you will understand my point. Look at River Benue and some other larger river bodies around. You see, when the water body is increased during the rainy season, you see aquatic plants floating on the water. To some extent, it makes fishing activities and even movement or navigation on water very, very difficult. It causes what we call the algae bloom. You see a lot of water plants, aquatic plants floating. Sometimes you also need to wonder if you think that these plants are polluting the water or they are introduced from one point to another by accident. But how then are they feeding well? How then are they flourishing on top of the water? I think the good news is that majority of them take up nutrients from this polluted water. One of my MSc students just defended, and her work was on phytoremediation using 2 aquatic plants of the river Benue here. We got the aquatic plants, collected water samples, and analyzed for the presence of heavy metals, chemical fertilizers, and herbicides. You know, Benue is an agrarian community, and majority of our work here centers on these things find their way back into the soil. No matter whether it is foliar spray or whatever you do, you find their way back into the soil, and there is leaching during rainy season. So all enters into the water. So the moment they are in the water body, the aquatic system is polluted. And when you analyze River Benue, for example, at very close points to sources of effluent here, you will see there are a lot of pollutants. What did we do? Collected the plants, planted them in this water. We fed the water to the planted pots or the potted experiments, and allow them to grow over time, and we see whether they are able to uptake these chemicals from the soil. The ones that grow on the water, we also analyze their tissues to see if they're able to uptake this from the soil. And then we now have the control where nothing happened. And you can see beautiful results. By varying the conditions where these plants are planted, we see beautiful results. Let me also tell you that in the case one yesterday, where Dr. Febu mentioned vehicular emissions, one of my MSc students at Cyprus, who has also defended last year, actually worked on air quality at 3 different points. I mean, pollution sources, waste dump sites, abattoir, and vehicular emissions at traffic points located variously in Makodi. We use gas monitors, which provided real-time updates at serious traffic hours, and we're able to identify the various gases that are present at these hours. Beautiful results. So you can now see the choice of which technique to apply, which technology do I adopt, which procedure, is it ex situ or in situ, when I'm faced with real life situation. It's born out of the fact that you have been equipped with this understanding of the concept of environmental monitoring, and you can handle these things in a very safe manner that results that can be comparable to any other place where researches like that have been done. So in life cases, water, soil, fauna, flora, and the entire health of the ecosystem, we can apply the use of biological agents as mitigation strategies to help better the health of the environment. So, what I want us to look at here is we have real life cases ranging from landslide detection, air pollution monitoring, that is toxic gases, flood indicators, that's an emerging case. We have had of flood cases in northern states of Nigeria where we know rainfall is minimal, although very devastating. Not to talk of, and then more recently in Middle Belt region in Nigeria. So it is very important that some of these things will be handled. How do we make use of biological agents? Either as monitors or as mitigation agents. Now, should you want to make use of biological agents from the wild, for example, if you are looking for bioindicators in the forest, how do you identify your species? How do you quantify your species? I know in one of your slides there's environmental sampling techniques. One of your slides is environmental sampling techniques. You have quadrats, transets, use of species lists, okay? The mark release recapture methods of insects. These are things that must be at your fingertips, depending on what you want to do anytime. So, if I am looking for mosses or grasses or plants in the environment of the species of interest, if I'm making use of quadrats, throw my quadrats, and within every quadrat, all the species of interest that fall within are counted. And then I can do my abundance table, frequency tables, and diversity tables at the end. If an indicator is present in an area, it tells me that there's a danger in that space. So if some species of mosses identified nitrous oxide are present in an environment. That tells us that there is an incidence of that, of the presence of that gas in that environment. So we need to find out what activities will trigger this in the environment. And if there's a factory or anything happening around that place, we have to tell them to stop, that they're actually polluting the environment. We can compound our research with use of gas monitors, and you can see that these things will be present. So allowing these biological agents at particular locations well on time will help the environment. But we need to know what they are. We need to know what they are. So I want us to agree firstly, I know the class is very, very large. Class monitor, you are going to divide this class into 3 sets. I'm going to divide this class into 3 sets.
We have already divided into 5, sir.
5 sets, beautiful. Yes, 5 sets, beautiful. So I am going to give you each group an assignment, okay?
Yes, sir.
That you will coordinate yourself and handle it. That either before the week of revision, you can do and forward to my mail, okay?
Yes, sir.
Or the week of revision, you can forward to my mail, and then we can wrap it up. All the concepts Professor Ofegbu already, and I don't want to go back and forth on it. Okay, he did much part of the work on my behalf, but we are together. So that's why I'm just trying to point certain aspects that I know you need to understand here. Okay.
Yes, sir. Yes, sir. So please, hello, Prof.
Yes, I'm listening.
Yes, sir. My colleagues, we will need the slides for this particular lecture.
No problem. I will. Before your this thing tomorrow, I will make it up and send it out to you.
All right, sir. Thank you very much.
So, what we have is that we have this module is well programmed. What we are giving you have been adopted and signed by the center, okay?
Yes,
as your lecture package, okay? So, but while we are discussing, there's room for addition because we are all professionals from different backgrounds, okay? And there's one concept inside in IPES, the concept of you unlearn and relearn. And I know I'm talking to a lot of you that are professionals. Some of you even know much better than we do. We are only trying to aggregate points here for you to understand where the mission of this program is heading. Okay, so I know if we are taking one-on-one, people from backgrounds in road construction, geography and urban planning, medical or biophysics. A lot of people will come here and tell you so many things. I remember somebody was telling Professor Fegu yesterday that why the lecture was very interesting, that he was just speaking his own terminologies. Okay, and he said, don't worry, I'll make it clearer to you. So I understand that. I know he has sent you slides of this module already, isn't it?
No, sir, not yet, sir.
He are not giving you the slides. I thought you have the slides already.
No, sir.
Okay. Okay. What will happen is that we'll forward this main slides of this to you, and I'll send the additional one afterwards.
You know, we have the other slides is this additional one that you are
No, this
taking
additional
now.
one. If you have the main slides, okay?
Yes, sir.
If you have the main slides, do you have issues on biodiversity surveys? Where do you have issues that you want me to comment personally here now, so that we can have our discussion flowing?
Okay, let me open the group so that or if you want to speak, just raise up your hand and I'll open the mic for you. Okay, Mr. Seso Ahang, want to speak. You can on your mic now. Mr. Seso, you are on.
Sir, good morning, everyone. Can you hear me?
Yes, we can hear you.
Okay. Good morning, everyone. Good morning.
Yes.
Thank you for the lecture. Due to the nature of my work, sometimes I go, I come out, I don't know whether it's network. I want to know the difference. I want to know the difference between you talk about habitat recovery, and I want to know the difference between habitat recovery and ecosystem restoration.
Okay. 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 I hope you are listening to me very well now.
Yes, sir, we are listening.
Okay. Firstly, habitat is the natural dwelling place of an organism. And ecosystem is the functionality of a habitat. That is the interplay between the living and the non-living components of the environment. So the habitat now can be a particular location, a particular site, and what happens within the habitat is about the ecosystem. So habitat recovery is to return that space reclaim that space that have been lost, that have been destroyed. In fact, when they say the habitats have been destroyed, that means the functionality of that habitat have been tilted. It does not mean there is no life again. It does not mean again that the abiotic forces are no longer there. In terms of size, it has been distorted. In terms of composition, it has been distorted. And remember, functionality of the ecosystem is a function, again, of the individual components. Okay? Have been destroyed. Listening, then the ecosystems goods and services. Hello?
We are listening, sir.
Okay. If the species richness of the ecosystem have been reduced or destroyed.
Thank you, sir. Let some other
the delivery of that is the supply of goods and services, the ecological benefits of the ecosystem have been destroyed. So habitat recovery is a totality of different principles coming into play to making that space, to recover or reclaim that space, both in functionality, in composition, and in size. Now, ecosystem what was the word used again? Hello? Restoration.
Okay, I wanted to know the difference.
Yes. So restoration in its own term means to bring back to the pristine state. Okay? To bring back to a pristine state. Now, recovery is a gradual process. But if you have to bring back to pristine state, that means the number in that's exact number if in abundance, species richness, and all the dynamics. Yes, you are talking about bringing back that forest to what it was completely. Then that's restoration. If it is back functionality in that space, okay, it means that it will grow back gradually through primary, secondary, and then tertiary succession if time will allow. And so these are the dynamics here. If it is revegetation, that means to bring back plants irrespective of species composition or the abundance of the species. And if it is afforestation, it means that there were no forests here before. Now we need forests so that other things can come into play. Yes, we can reforest. We can also bring in forests where they were not there before, all with a view to enhancing the functionality of the ecosystem. So whichever way you look at it, it is only when it is in totality you would have said that that habitat has been restored, or the functionality of that ecosystem has been restored. I don't know if I answered your question. Hello?
So I think you've done justice to the question
Good morning,
about
sir.
Okay.
habitat recovery.
Yes.
Next person.
Good morning, sir.
Yes, I'm listening.
My name is Doga Terry.
Okay.
Out of all the environmental monitoring indicator, air quality, soil and sediment quality, water quality, yes, detailed information has been provided about their sampling techniques and analysis techniques by Dr. Fuego. But another critical indicator, which is the biological component, the biodiversity, which you are trying to touch, I think much has not been provided regarding the sampling tools and techniques. Same goes with the analysis tools and techniques in that aspect too, before we talk about the regulatory threshold. So I don't know if you help us do justice to that, so that in applied context, better be equipped. Thank you, sir.
It's okay. Now, if you're talking about sampling techniques, like I said, depending on the species of interest, there are different tools. We have quadrats, light transects, use of species lists, the mark release, and the capture method for insects, and the measurement of abiotic factors, just like we measure that in sediments and in air quality. Now, what are quadrats? Quadrats are, or a quadrat simply is a four-sided wooden tool. It could be let's say 1 meter square, 2 meters square. As a professional, for example, what is the species of interest? Are they grasses? Let me also define some basic terms. Grass is simply a herb or a herbaceous plant that is not too tall. It grows between 3 feet, maximum 3 feet from the ground. There are giant grasses, quite okay, but most commonly, maybe depending on the location where it is found. Now it has so it does not grow too tall because the roots are fibrous. Roots don't go too deep into the soil, so it doesn't stay too long. They are annual plants. We know what are grasses. There are also, but there are dicots. So these ones we call them forbs. They have broad leaves. They don't grow too. They have vines. They twine around. Some of them, like beans. Not all beans form twines. Some are just short, just like 30 cm from the soil, but they are not grass. So they are herbs. Okay? We don't have shrubs. These ones are woody in nature. They grow a bit off the soil, maybe between 5 to 6 feet above the soil, and they branch, but they are not trees. Trees are woody plants that are large. They branch from 7 meters above. So a tree that have not fully grown to a tree may be mistaken for a shrub. Okay, a tree that have not grown fully may be mistaken for a saplings, young saplings that are still upcoming. Now, having given you these basic distinctions, if you go to the field to sample, what is the size of the field? And what is the nature of the species of interest? If it is not too tall species, and if the size of the plot is not too much, first of all, you can decide to divide the plot into maybe different subplots, and then you can also decide to make use of quadrats of different sizes of interest. So if you take, for example, a 1 meter square quadrat, what do? You stand at a point and then throw the quadrats around randomly. Randomly because there's no bias in what you are looking for. There's no bias. You want to see that enough samples are collected. So if you stand at a point to throw along, if you divide the space into X and Y axes, you can throw the quadrats randomly. And if the quadrats are thrown well enough, plot of land, and you throw up to 50 quadrats randomly, you would have gotten representative samples of what you are looking at. Now, if you throw the quadrats, all the species of interest where the quadrat lands are counted. They are listed, and if you are professional enough to identify them, you identify them. Once you identify them, you list all of them, and then you go and draw your contingency table. I threw 50 quadrats. You list all the species in all the quadrats, and then you can handle frequency of distribution. You can do abundance of the total, that's the richness of the whole plot. You can check which species is dominant, the most abundant. You can do what we call relative abundance. You can do species diversity. So these are core ecological principles. So if you need a detailed lecture of that beyond this, maybe I will make an additional note and then attach to the slides for you so that you can learn. Okay. Now, there is also a statistical tool can be used to manage your data. For example, yes, it is not enough to just identify one species. It's to also say that, yes, within a 1 hectare space, this particular species was identified, and in terms of distribution, this is the range, this is the percentage frequency of occurrence, this is the abundance of this species. The statistical tools will bring them out for you like that. But what do you make use of this data for? If it is just for the purpose of incidence to show whether the species are there or not, that's not an issue. But if you are going to use the value for another statistical analysis, reasons, then you can go into more professional levels. But as a way of saying that, yes, I've identified species and this is how they appear, that is okay. The next one is line transit. There's line transit. Transit simply means taking an overview of an area along a straight line, and perpendicular to that space, you take another line, X and Y axis. Then what you will do is that, because you have seen that this place is too large and the species of interest are more than one, I will not be able to just use quadrats here. So what will I do is this: you walk a distance, maybe 5 meters to X and Y axis. So for every 5 meters on both axes you stop, you have created a quadrat of 5 meters, isn't it? You walk to the right along the S axis. From there again you walk. Sorry, I'm in a class. Tell them to give. So sorry for the interlude. So you walk along your S axis, 5 meters, you stop. You walk along your Y axis, 5 meters, you stop. And when you join yourself, you discover that, yes, you have created a 5 meter by 5 meter quadrat. And at that point, you can take inventory of all the species of interest. If there are shrubs that you can see visibly, all you need to do is just to count them. And if you identify them on spot, fine. If you cannot identify them on spot, you take snapshots, or you can collect leaves, flowers, and if possible roots. Take it to your herbarium unit for identification, or look for a taxonomist. They can identify it for you. So if you do this round, you would have taken more than 80% of the space into consideration. And at that point, you can assert a professional level of authority, saying that, yes, I actually surveyed this space and this is what I found here. So that is that with species list. Species list is just a simple assay. How do I mean? You have a predetermined list. For example, you in this space, out of 124 yesterday, I don't know how many we are now. This is about what you call Teda. Anybody call James? Anybody call Uko? Anybody call Joyce? So let us go and arrest them. So when we go there, we'll be looking for Anna, Joyce, tengu, tena. Now, if we see them in more than 2 or more than 3, depending on the frequency they occur there, we will be saying that yes, we have seen the people we are looking for. How then do we determine which of the tenants, or is it every tenant that is a thief? It is from the list that we will know. So it is like, so you now go to the field with a predetermined list, and then you are looking for the species of interest. Meters in that space, there was one tenant. Then for every 20 meters, there was no tenant. And then you come up with what we call a phytosociological data that tells you how many tenants are in Wurukum, how many Tengu are in Makodi. Depending on what you want, you can now present your result. Like I mentioned before, there are what we call keystone species. Keystone species are species that, okay, hold on first. There's what we call leading species. Leading species are species in the environment that provides or dictates the tune under which other organisms thrive. I repeat, they are the leading species are the leading species in the environment. They are the predominant species in the environment. They may be very few, but they provide microclimates under which all other ones will thrive. So I'll give you an example. If you go to the forest or the wild, for example, and you have a very large tree, you will go under it. If the tree has very well protected canopy that does not allow sunlight to penetrate it, I bet you will not see grasses. And what do I mean by them? Don't be surprised. So without sunlight, you cannot see grasses. In fact, any forest you go to, just raise up your head under the tree and you will see that there's sunlight coming out. That's why you can see grasses. They are photophilic. They are not shade tolerant. And so without sunlight, you cannot see grasses. So if the shade of that tree is very perfect, sunlight will not penetrate. So you know what it means: a microclimate that either discourages or encourages the inhabitation by other species in the environment. What if it provides enough shade for other birds, mammals, to live on top? What if it bears fruits that other animals can feed on? You see a consortium of activities going on there under the tree. And let me tell you that if there are special birds that live under the canopy of that tree, any day you fall that tree, you will lose those birds. And then your father will tell you that in those days, in this our farm here, you used to see plenty of these birds here. You used to see plenty of these birds here. Now, people have hunted them. People have done this. You will not know that the truth of the matter is not the noise. So sometimes it's because the trees, they live under a shade that have been removed and they cannot survive under any other shade. So they have left that environment. So may not just be in the space, it may be just in the composition of that space. If the species of interest have been destroyed, you will never have the same life in that habitat again. So, leading species provided the conditions under which other ones thrive. How about keystone species? Keystone species are the species, either plants or animals in the environment, that performs key functions that not other animals or plants perform. Hello? If you buy a plot of land, for example, and you want to build a factory or you want to build a house, the moment you acquire that space, look for an expert. It may be a school, a company, a hospital you want to build. Look for an expert to make you understand what happens in that environment naturally. For example, when you are approaching some very big companies, sometimes you will see some patches of trees, like a mini forest on your way inside, that are guarded and protected, or they occur behind the main building or behind where the activities are ongoing. And then you now see where the administrative block or the quarters and every other thing is there. You ask very well. Those things are not just forests or bushy areas that have been left or abandoned. They are actually what we call green reserves or green areas, otherwise what we call professionally as biodiversity offsets. And what is biodiversity offset? Biodiversity offset simply means the relics or the remnants, the representative of the prominent species in that environment prior to the operation, the construction, or the taking over by the company or by whatever is happening in that place now. So what we are saying is that as environmentalists, provide these biodiversity offsets so that those ecological principles ongoing in that place can continue to remain. You can still tap into the resources of nature in that place while you are doing what you are doing. Now, so if a keystone species there, its function is to serve as windbreakers, and you didn't know, and then you now come and say, I don't want this tall tree, remove all the giant trees there. What you have done is that you have destroyed that, what will protect that environment. You see, for example, in the university, I'm sure in Agric here, Justum now, where it was a forest, you would have seen that there are so many trees here, but there was deforestation. I mean, they cleared the space and then they built the university. After building, they started planting different trees. Why? Because we need the trees back. But ordinarily, a careful examination would have been taken. Take to where started, like it is being disturbed, maybe farm area or some things, and then allow the thick vegetation to remain to serve as a biodiversity offset. And then you can see that the environment will naturally have been protected. Okay? Even in habitat reconstruction, you need to tap into the biodiversity offset of that place so that you can reconstruct what has been lost. Now, I only went that deep so that you can understand what I want to say. So keystone species must not be touched in an environment. So you have destroyed their relevance. You have taken away their functionality in that environment. So how then do we identify or monitor presence of particular animals in the wild? How then do we have access to them? For insects, there is a common process called the mark, release, recapture method. What do? Use a net and then sweep your nets to catch the insect of interest. After catching 2 or 3 or 4 or 5 at a time, record the time, identify the insect you have captured, and then mark them. Use an ink to mark them, and then you release them back into the environment. After you have released them, come again after another time, a regular time. If it is once 1 hour every day for the next 1 week, if it is going to be just any regular time, you return back, you do the same procedure again. If you capture exactly what you captured before, and you know these animals are gregarious. I mean, they are not static like plants. So you are not likely to meet the same thing where you met it yesterday. Because they are migratory, they may leave that space, others may come in again. So what will happen is that if you come the next time, you may either capture the same thing or more or less. So if your experiment is programmed such that you will now take samples over a period of time, you will now report your findings. At time T, these numbers were cut. At time these numbers were cut. And where there is similarity, you can say yes, total number of these that were cut, this space is like this, total number of this other space that were cut like that, and you can make your can publish your results as supposed to be. So it's quite tasky ecologically, but it's not undoable. You only make use of professionals that can do it. In fact, for environmental impact assessment team, not one person. Yes, somebody may be the consultant, but he doesn't do everything. Not one person does not do every other thing. So you see an analytical chemist is there. Okay, you collect samples and you hand over, he will do analysis for you. In laboratory technologies, science laboratory technologies that can analyze for microbial quality of water, of soil is there. You will now see an ecologist, either plant ecologist, yes, that will tell you the sampling procedures that are agreed scientifically and that can interpret your results. You have a plant systematics, or even the ecologist, if he can identify the species for you, he identifies them, or he helps you to identify through other ecological means, and then you can make your informed decisions on biodiversity. That yes, this is how to report it, this is what I have done. Now, there is also, you can capture other animals. Is it ants you are looking for? Is it rodents? Is it ungulates that run around? By using fecal pellets, their fecal drop is their shit. If you identify, if you know the kind of animal you are looking for, I know in those days we go to the farm. Your father will tell you, see, grass cutter is in this farm. You say, how? Where did you see it? Say, look at their shit. See, they're the one cutting my rice. See, come and see how they eat it, how they cut it. And he'll tell you their activities. That will tell you, before you know it, you go and put traps, and then they'll catch it. Sometimes it is this guinea fowl you plant, and then you see that their legs are everywhere. They go out to do a trap, and the next morning they say they have caught guinea fowl in the farm. So you identify the type of animal of interest, and then you can lay the appropriate trap. Okay, so there is trapping for both rodents and undulates. Okay, and you can either identify their type of hole, caves where they hide, or their fecal pellets. It is their footprint, and so it is the sound make. For like you're looking for ant, you may be go near it, but you are almost, or maybe lion. You want to hear, once you hear the roaring of the lion, you know that lion is in this place. They even use helicopters to monitor around, to move around the space to identify some particular dangerous animals. So that is basically the kind of information I can give you on the biodiversity. Otherwise, you measure abiotic factors. Yes, ecosystem functionality, you have to do with both biotic and abiotic components. And so when we talk about plants and animals, also talk about non-living things, the gases and energy, the chemicals in the environment. So how do you measure them? This have been taught already. You have gas monitors that can tell you the concentration of gases in the environment. We can actually measure the presence of chemicals in water, in food, in soil, and in air, quantify them. So this is basically the ecological approaches to surveying. So, hello.
We are with you, sir. We are with you, sir.
Prof, can go ahead, though. I think they are all listening.
Hello.
We are with you, sir.
Yes. Any other? I hope my the response is okay, right?
Yeah, the response is quite okay, but a few persons seems to be lost about the direction of the lecture. But I understand that it's just a bit of maybe brain disconnect from what we've been taught before, from what is being done now. I think this part of the lecture is more physical, like it's touching things that we can feel and see. Can you hear me, sir?
Yes.
So no, I'm saying that a few persons seems to be lost, and they've made those comments on the chat. So, sir, if you can help us connect with what we've learned before, because right now, what we've learned before was about soil, air sampling, and the matrices to look out for.
Okay, the guy asked me of ecological survey, biodiversity survey.
Yes, sir.
Hello.
Yes, sir. Yes, sir. We are with you, sir.
I am actually, yes, in one of your slides, it talked about environmental sampling techniques.
Yes, sir.
And I'm responding to that question on how to use quadrats, transits, species list, mark release, and recapture method. So what is difficult to understand here?
A few of us are. There's a bit of
you said the slides have not been given to you, and I said I agree, and I will forward the slides to you after the class.
Yes, I think maybe that is where the disconnect is coming from, since they are not seeing exactly the slides. At times audio visual can help, sir. Okay, sir, your mic is off. Prof, your mic is off, sir.
Is it me or Dotoko?
Okay, any of you, sir. I think any of you can come in and clarify, sir. No, from the
Let
chat.
Dotoko clarify it, but I think they should understand this as the biological component of the whole environmental assessment.
Yes, sir.
Once they understand that, they can also count the number of butterflies in their environment, the moths,
Yes.
and all that. They should also understand that those things are part of the biodiversity that we are talking about. You monitor the environment. It's not just about human beings or soil, air, and water. Within this ecosystem, these other animals and insects, like I mentioned before, also dwell there. So he was talking about, when he mentioned quadrant and all that, how do you count them? How do you account for their numbers and their presence? For example, when you use things like pesticide, you keep using these herbicides and all that. You discover that most of these things that naturally you see them around are no longer there. They have migrated away from their natural habitats. So in some cases, what they do is they allow those places to regrow naturally. That is when you are talking about restoration and all that, you bring in some other incentives within the ecosystem that would attract them back, bees and all that. Those are the things that our lecturer was trying to make us understand. I think he can take it from there if this is helpful. Thank you.
Thank you very much, Dr. Fegbu. The person who asked the question, I actually wanted him to respond if he had all that I said. And those who feel they didn't understand, he has made that clarification. So any other concern, please?
Any other concern? Kavner, your hand is up. You can speak. Mr. Kavner, over to you.
Yeah. Thank you very much. I have a little question, but thank God Dr. Ofebu is here also. It's particularly on the air monitoring. When you are trying to get samples, that is to monitor an environment, that is air, you use in situ or the ex situ. Now, I believe the ex situ has to do with the lab-based or traditional tool method of sampling, while the in situ is for imaging tools. I understand that using in situ, you can get real-time data. You understand? Because this concerns monitoring devices and the use of satellites in the orbit. But my major concern now is, how do we harvest samples to use in the lab, that is in an environment like air, when testing an environment like air? How do we harvest the samples to take to the lab and use it to get our data, sir?
Okay, sir. Over to you. Dr. Oko.
Okay. So how do you harvest your samples and take them to lab?
Particularly
air. Air. Okay. Now let us look at it from this angle.
Okay, sir.
Can I go on?
Yes, sir, you can go on.
Hello?
Yes, sir.
Okay. Now, Okay, my point is this. First of all, you monitor the environment with a view to identify. Now you're talking about quantification.
Okay, so what it means, how can you, like, when you are looking for a mattress like air, when you are using a mattress like air for your analysis, how can you harvest the air you need? That was his question.
Don't worry, I'm going there. I am coming from a different perspective. If you have a monitoring agent, for example, if you are using a biological agent to monitor, you can actually detect the presence of that particular substance in that organism, and you can make use of it if you use a monitoring agent, a life monitoring agent. Okay, while there are the samplers. This you were thought of gas samplers, these passive and active samplers. Do you remember that? Hello.
Yes, sir. We remember, sir.
Okay. So, what was the use of the samplers, if I may ask you?
Mr.
Okay, now the use of the samplers, when you want to harvest from air, there are different devices, that is samplers you can use. If you are using the in situ methods of harvesting, we have the NQ7, NQ2, which used to test carbon dioxide.
The question I'm asking you now is that what do you use the samplers for? Is it just
basically the samplers are used for
or to capture? Does it trap?
Okay, no, the samplers are used to detect. Sorry, to capture. Yeah, to capture for mapping.
So if you capture now, so if you capture, it means you can make use of them, depending on the parameter you have used at a particular time.
Mr. Abdul Malik Mohammed, your hand has been up. Abdul Malik Mohammed, can you speak?
Okay, good morning, Doc. Good morning, everyone. Hello?
We are listening.
Okay, good morning. Please, can you hear me from there?
We can hear you, sir.
Okay, good. Yeah, good morning, sir. Thanks for the lecture. In fact, I've learned some few things from the beginning of the whole thing. But one of my colleagues asked a question regarding what do you call it? Habitants and biorecovery, and which you explained. So I was privileged to serve in Niger State, and precisely Mokwa. So last year we experienced what we call flood. We experienced flood because I'm based there now. We experienced what we call the flood disaster, and in which I have interest of working aligned with this flood, the incident of the flood that happened. So I want, if God can put me through, how can I align the flood? I mean, the what do you call it? The bio recovery, because during the flood, I think there was a lot of happenings in which life were lost and other what do you call it, atmospheric goods. So I don't know if we can align this with what Doc is discussing at the moment. I don't know how Doc can put it together so that it makes sense to me, sir. Because I'm coming from a different field, just like most of us here. So I've been looking forward to discuss this if it can be aligned as a work. Thank you.
Okay, over to you, Doc.
You had the flood experience, right?
Yeah, there was this natural disaster in Mokwa town in Niger State. It was a national disaster. So he's asking how the recovery process, how can it be done?
Okay, before we talk about recovery, what was the stressor element? Try it. Hello? Hello?
Yes, I can hear you, sir.
Yes. So I am asking, what was the source of flood? What was the source? Was it from natural rainfall or water came from somewhere?
Natural rainfall, sir. Natural rainfall.
Okay, natural rainfall.
Yes, sir. Because
now this is what we do. Please, I don't. Hello?
Yes, I can hear you, sir.
Okay. Now, some of these things from the water forecast, we can prepare for these incidents that there's going to be a flood disaster this year, except if we didn't adhere to the warnings, or maybe they fail to intimate the public that this is going to happen. Because once it happens, there's nothing you can do at that instance. But by way of preparing ourselves, depending on the intensity of flood, how do we collect runoffs that will, from one point to another, that will not continuously go downwards and destroy other sources of livelihood or the environment? Trenches and drainage canals, waterfalls or rainfalls, yes, they will run off, but they will be minimized, and much of it will be channeled into a collection point. That is one. Secondly, depending on the size of the location, it is very important that we can plan the area such that the living areas, agricultural lands, and then the ungoverned space, we can determine what we do to this space as a we can construct dams that water collected here can be stored here for this purpose. People should not live along the floodplains. So there are technical things, but ecologically, if this is a floodplain zone, and so we can determine how we can plant particular tree species that will serve as breaks at particular instances. First of all, they suck up water from the soil, so the soil is not always damp. Okay. Secondly, they make use of water from the environment at intervals such that we can even make that space a more productive venture. There are types of plants. If you go to the south coast of Nigeria, The mangroves at the coastal line of Nigeria, they are very rich biodiversity resources. And so if we have mangroves planted where people are not, instead of allowing mangroves, they dwell very well inside inside water bodies. This water does not stay continuously. It only comes during the flood time. So if you have mangroves at that belt over a large expanse of land, it can actually help to reduce the pressure of flood when it comes. And then beneath that, you can now have more rainforest trees. The region you are talking about is not too different from or too far from the other side. That's Kwara State. That's more of rainforest belt.
Yes, sir.
Yes. So you can see that if your location is downward, of course, there is more, the tendency of water flowing into your area is more. But how then do you hold back this water? So it's to look for species that can survive this intensity of water. So there are mango fishes. If you go to Calabar, for example, directly behind beneath the coastal line is mangrove swamps. And then beneath it, inwardly again, is a rainforest belt. And then you now have the town, which is more of savanna grassland, until you leave the entire cross river this way. And the same thing with Akwa Ibom and rivers. So apart from states like Delta, where the water body comes into the major hinterland, although not as much as the Atlantic Ocean, but you see that mangroves surround it all over. This is what they call the creeks. So we can actually make it more profitable venture. There are so many resources that can be tapped from there. So it's not just a single planning system. First of all, the weather forces have to be taken into account every year for effective monitoring. Secondly, there must be a serious, intentional, and conscious town planning system, so that even where it is left as farmland, people don't just farm and lose their crops. Again, when do you farm? We can actually change our farming cropping system, because if between July and September the water volume is too much, then we can target farming of rice as the water is receding, so that we don't do things and then we suffer and say floods have come and destroyed us. But again, it has to go with effective weather monitoring.
Doc, thank you very much. You have done.
I don't know if I address your concern.
You have done serious justice to the question. Mr. Ajoko Philemon, please ask your question. We are listening, sir.
Yeah. Good morning, sir. Yeah, good morning, sir. Good morning, my distinguished classmate. I have a concern and also have a contribution. When Doc was talking this morning, he talked about flood indicators as an emergent field in the northern part of Nigeria, and I agree with him completely. Flooding disasters have been on the increase in the northern part of Nigeria due to what we call the survivor theory. A lot of people are actually cutting down the little trees that survive in that part of Nigeria. And when you give them a professional advice, they'll tell you, we cut down these trees to sell and then get money to buy food. And the climate change impact is also coming in. The rainfall duration is short, but the intensity is high, leading to huge runoff, which account for flooding. And so flooding disasters has actually been happening recently in that part of Nigeria. But again, now my concern is about the monitoring of noise. The two pros have dealt very well to other aspects of the environment. Now I want Doc to throw more light. How do we monitor noise? Because noise level has been increasing of recently. So either as how do we monitor noise level using a biological method? Thank you, sir.
Hello?
Hello, where are with you, sir?
The issue with noise has to do mainly with our resolve to live in a peaceful environment. How do I mean? Is it volcanic eruption or earthquake? Every other noise from the environment is human induced. Which is not a persistent something. During construction, the activities will always produce noise. So when that happens, what do we do? So if we have a mining, a quarry site not too far from human habitation, when they are blasting, you will definitely hear noise. There are some very far from the residential areas where the activities are not always being felt. But again, if you shift away from one town, you are getting closer to one small village. So if you are far from noise here, somebody else will be getting closer to it. And then that is that. But again, I think what we can do is that depending on a particular project, certain activities can be done where the impact can be less felt. So if the impact is more during the day, we can shift that activity to the night where the impact will be less. If not, we cannot tell people to leave this area permanently because this factory is now here. So it's to when a design of a project, at the construction site or at operational level, is being presented, Then we plan a mitigation measure, how we can muster effect by way of either changing the time of operation so that the impact cannot be less felt. But noise affects humans, it affects many animals have actually withdrawn from their natural habitat, or they have changed habitation because of the pressure of noise. Because noise is interpreted as danger to animals. And it also constitutes a health risk to us as humans.
Thank you, sir. You've done
See, today we have mass every
great justice.
Network mass everywhere. In those days when we have a night terror, if you go closer to where the mass, even though as giant that it used to be, you will see, you'll be hearing noise. It was. You don't know whether it was dangerous or anything. But today we have modern facilities that are in place. Such noise are not heard again. So first of all, we have to have a technological development that can boycott certain processes that causes issues for us. That is one. Secondly, we must as a country determine that our activities that will produce loud noise should be done or carried out where it is far away from human habitation, so that people can now enjoy their peace. We don't have so much airports here. How about people living in the UK, US, where there is airport everywhere, or so many number of planes flying? So that is what I can say. Okay. Yes, industrial activities should have some designs that can muster their noise effects. So I don't know if I've addressed your concern.
Well addressed, sir.
Thank you very much.
The last thing you said,
okay.
Proper town planning will help us plan properly. Industries are located far away from residential areas. Then churches or mosques will also be located away from residential areas, and they not be allowed to use a very big loudspeakers to disturb or cause noise pollution, as it were. So all of those, government will help us regulate.
Yes.
Any question?
It really has to be government, though, because even on this platform, if you say church is making noise, somebody may not agree with you.
It's true. Any question?
It's okay.
Any question? Okay, then I don't see any hand up again. If you want to ask a question, you can raise your hand. If you have a question, you can raise your hand, and if you granted permission. Okay, I can say Nitse Kwado. Nitse Kwado,
Nitse Kwado, Wilson Ogbole.
Yes, sir.
Morning, sir.
Yeah.
Morning, sir.
I want to say, I would just want to comment on the thing that you
Yes,
say
you're
you will
welcome.
not agree on the church being noise, making noise.
Wilson, you can unmute
We are
yourself.
listening.
Hello.
Wilson, we can't hear you. Nitze, over to you again.
Hello, can you hear me?
Okay, Jubri, you can unmute yourself too.
Jubri, you can unmute yourself too. Okay, sir. Good morning, everyone. Good morning, sir. Sir, my question is, I want to know.
If you're not clear, you can type your question in the comment section so that I can also help read it out from here. Because it seems a lot of us are struggling with network. So you can do well to type your question in the comment section.
How aquatic plants fight to remain.
We did not hear the last person. No? We did not hear you properly, sir. We only heard aquatic animals at the end and you are off. That's why I'm saying you can type your question in the comment section and it can be, I can read it out from here. Okay, Nite, Mrs. Nite Kwado Priscilla.
Me, please.
I was saying that concerning the noise from churches and mosques, if the noise is coming from the church is too much and it has the people around go to complain, like in offices of Nezra, it can, because Nezra regulates noise, so the churches can be shut down, because there are some mosques even in Lagos that were shut down due to the noise pollution that was disturbing the particular area. Then recently in Lafia, the NTA station here, there's a church directly behind because the noise was obstructing their own equipment and also disturbing residents of that area.
All right, thank you very much. Initially, I shut you down. I was thinking you want to.
No, I was not
Yes,
asking
I
question.
agree
My own
with
was
you. That's why I said
contribution.
it can actually be government.
Yeah, it can only be government. Thank you,
Yes, it's
Priscilla. Initially, I
okay.
shut you down. I was thinking you wanted to.
No, I didn't want to ask question because the course I'm just following it small. I've not understood it very well like that. But it was concerning the noise issue that I
Thought you
wanted to
wanted to say
contribute
we
to.
shouldn't mention your church. Oh.
No, it's not church.
Okay, we understand. Thank you very much for that
Then
contribution.
for issue of even telecommunications, these they are marks, because like Nezra office, they enforce them to use be using CMGs. So the ones that are still using listers, because there's a sound level permitted. So if it exceeds that limit, it's also being enforced.
Okay.
Yes.
Somebody is mentioning noise from
Thank you very much.
hotel generator.
From
Noise
listers.
from lister generators from hotels too.
Yes.
My family house in Makodi, a club. Someone just
Yes.
opened a club close
So
to it. So during this Christmas
those kind
period,
of issues should be channeled to Nezra offices if you know where they are located, because
you
that
work
is
with
their mandate.
Nedra. Thank you, ma.
I
You have
have
answered the
people with
question.
them.
Okay.
Yes.
Thank you very much. I appreciate it.
Thank you, sir.
Thank you. Okay, any other question? Okay. Okay, there are no more questions. So you said you are going to give us group work to do. So maybe when you send it later, we will pick it up and run along with it. Okay, Mr. Jubri Adamu, you are back. Please unmute your mic.
Yes, no, I'm going to. I'll send that. I'll send that.
Jubri, we are waiting. Jubri, ask your question, sir.
Good morning, everyone. Good morning, sir. Sorry, I had a network glitch. So my question is, I want to know how aquatic plants like water hyacinth and so on, water lily, helps in phytoremediation.
Phytoremediation.
Okay,
Yes.
thank you very much, Jibrin. Okay, thank you very much. Okay, let me start with this. Phyto simply means plant. And so what you have there is use of plant for the purpose of remediation. Now, in bioremediation, we said we are making use of biological agents that can remove the pollutants from the environment. Now, water lily, water hyacinth you talked about, they live on water. Lemna species, they live on water. And are in the water. So what they do is that they absorb materials from the water solution. All the elements we talked about are dissolved in water. They are dissolved in water, so by simple osmosis, they absorb this material from the water body. Same way they expel
we can't get you very well. Your network is breaking, sir.
Their respiratory products through their cell membranes into the water bodies. So all aquatic plants have what we call the sponges that their cell membranes into the water. That are known for storage. Their leaves are made up of parenchyma. Their leaves are made up of parenchyma.
It seems network has kicked our lecturer out. Professor Fogbo, if you are there, maybe you can take over from there, sir. Oh, he's back. Dr. Oko, you can unmute yourself, sir. Dr. Oko, you can unmute yourself, sir. Yes, sir.
Yes, thank you very much. Can you hear me now?
Yes, sir, I can hear you, sir.
Okay. Wow. Hello.
Who can hear you,
Hello?
sir? Yes, sir.
Okay, thank you very much. So I'm saying that the aquatic plants have very thick palisade tissues lining the leaf surfaces. Now, the epidermis is very thin, and the epidermis is the outer layer of every biological organism. So the epidermis is very thin, is single layered, and beneath the epidermis is a spongy mesophyll, which is made up of parenchymal tissues, efficient for storage and absorption. So through simple osmosis, nutrients dissolve in solution, move from region of high concentration to region of lower concentration across a semi-permeable membrane, which is now the thin epidermis, and it provides nutrients to the water plant. So a container of beer, I think he naturally will be drinking the beer, isn't it?
Yes, sir, we are more of Christians here, sir.
Hello?
I don't drink. Yes, sir. Hello, sir.
Hello, are you talking to me?
No, it's Doc, sir. I can't hear Doc again.
Probably network challenge. Are there questions?
No, there are no questions, Prof. I think the lecture is quite understood, and we look forward to getting his material for the group work.
Yeah, we will. We'll see what we can do, and then wrap up by tomorrow.
Okay, sir.
But I think that there's an afternoon session by 1, correct?
Yeah, there's an afternoon session by 1.
Okay, so I think you'll be able to send the material before then.
Yes, sir. And we wanted to wrap up from here so that we can have with the candidates, we have a brief conversation before our class by 1.
Oh, please go ahead. I think Doc is having some network challenges. Just go ahead and wrap up.
Yes,
for
no,
me,
the both of you,
I will leave the classroom now.
Can exist, sir.
Yeah?
You can leave us alone, sir.
Yes, I'm doing that. I know I'm doing that now. Don't worry. Thank you. Okay, thank you very much. See you guys by 1.
Yes, sir.
And you?
Yes, sir.
Okay. So did you get what I was saying?
Yes. Not very well, sir. It's actually echoing, and the network is kicking you out too.
I don't know why the network is like the.
We'll get to it
Now I was saying that the outer layer of the water plant species are very thin.
Got that clearly. No, we got that before network kick you out, sir.
Okay, so the materials in water, the solutes have already dissolved inside the water solution. So what happens is that the water is in constant contact with the plant body. And so materials through simple osmosis move through the water into the plant body. So, and you know, osmosis is movement of solute from region of higher concentration to region of lower concentration. Now, because there's more pollutants inside the water than the plant body, the plant body is more lower concentrated than the water body. So materials will now move naturally through the water, from the water through the plant body into the through the skin into the plant body. So the epidermis is now the semi-permeable membrane. In
The epidermis is a semi-permeable membrane.
nutshell, aquatic plants are able to do that job of phytoremediation because they can uptake So what matters is for you to identify the particular water plant that makes use of certain pollutants that can either bioaccumulate or biopile or biomagnify or biostimulate of these materials inside the water body. So there are different processes or techniques involved in bioremediation. So it is when you get my slide, you will see those processes. Then I'll give you my assignment and you can do. So thank you very much. Did I address your question?
Yes, sir.
Yes,
You
sir.
did,
Thank
sir.
you, sir.
Thank
Sir,
you,
before
sir.
you go,
Let's go to the reaction on our form and send Oga some love.
before you go,
Just
sir.
tap and send Oga some love.
Thank you so much
On
for
the
the
reaction,
very
go to the
thank you, sir. Well done.
reactions, this thing, and send Oga love. Oh.
Sir, before you go, one important question, please.
Okay.
Oga, our time is up. Our time is up, please.
Thank you.
I have an important. I know our time is up, but I have an important question.
That was why I said drop the question in the chat box.
Yes. The question
Our time is up, please.
Thank you, sir. That's right.
We still have another class by 1.
It's coming back.
Thank you, Doc. Doc, you can exit now so that we can have a brief meeting. Hello, Doc. Okay, good. A lot of people are leaving the group. Oh. You will now come and